Hi, in this video we're going to talk about rules for integrations. There are some rules that we have to use once we integrate functions or sum or difference or product of functions. In particular, one is called the constant rule, or better, it has to do with constants multiplying integral. And it has this form. Let's say that we have an integral of a constant k times a certain function f of x in dx. Well, the rule tells me that I can basically forget about this function and bring it out of the integral. So the integral is just going to be what concerns the variable x. It means just that k is going to multiply any result I have here. The other rule we're going to see is the sum of the difference rule. The sum of the difference rule tells me that if I have an integral of a sum of two functions or a difference of two functions, remember parentheses here, in dx, this integral will be equal to the sum of the two integrals. So I'm going to have the integral of f of x in dx plus or minus the integral of g of x in dx. So I will have to solve first the one integral and then the other one. And in the case, of course, I have a sum, I can just sum them. In the case I have a minus here, I have to be careful which one comes first and observe the order. This means that if I have a long expression, like for instance an integral of a f of x plus b g of x plus c h of x minus d k of x, all in dx, and therefore we need an extra parenthesis here, the integral is just going to be, following the constant rule, a outside of the integral of f of x in dx plus b, it's a constant, so b is going to multiply the integral of g of x in dx. Then we're going to have the integral of h of x multiplied by the constant c in dx. And then we have a constant here that it's d with a minus in front, so I'm going to bring out d, and I'm going to calculate separately the integral of k of x in dx. Remember that every time that you do this splitting of the integral in many different pieces, I will have to write the dx here, the differential it's called, okay? And I will have to repeat that. dx, it's actually a fundamental piece that I cannot forget when I write down an integral. It tells me which variable I'm integrating. So let's see some example. Let's pretend that we have this integral. So we have an integral that is 3x squared plus 5 times e to the power of x minus 2 times the cosine of x in dx. Now I know that using the sum or difference rule, I can just separate this mega integral into small integrals. So I have the integral of, for example, x squared in dx, then I have plus 5, the integral of e of x in dx, minus 2, the integral of cosine of x in dx. Now I solve the first one. The first one tells me that I need a function such that the derivative is x squared. So I will have, by power law, that this function is x to the power of 3 divided by 3. Then I'm going to continue with the second one. I'm going to have plus 5 times what I call the antiderivative of e of x, which is the same function, e of x. And then I'm going to get minus 2 times the antiderivative of cosine, which is just the sine. Now, I didn't forget, or I forgot a little bit, the constant, right? So in principle, I can write constant number 1 for the first integral, plus constant number 2 for the second integral, plus constant 3 for the third integral. But I can just don't write that and just say that this will be equal to a constant. For example, I call it capital C belonging to R, such that this capital C is going to replace these three constants. At the end, the sum of three constants, it's a constant. So I'm just going to simplify now what there is to simplify, and apparently it's only these three, and get my final result, which is just this one. Okay. Now, example number 2. Let's say that I want to solve the integral of 2x to the power of 4 plus 8x to the power of 3 minus 5x to the power of 2 plus 7x plus 2. Again, I'm doing a little bit the same. Here I have a polynomial degree 4, so every time I will integrate, I suspect that I will go down 1 degree, right? So I will have that the first integral gives me a 2 outside, it's a constant, times the integral of x to the power of 4 plus 8 integral of x to the power of 3 minus 5 integral of x to the power of 2. I forgot here the x. Let me add the x. Plus 7, the integral of x in the x, plus 2 to the power of what? 1 in the x. Therefore, my solution is going to be 2 times x to the power of 5 divided by 5 plus 8 times x to the power of x to the power of 4 divided by 4 minus 5 times x to the power of 3 divided by 3 plus 7 times x squared divided by 2 plus 2 times x plus a generic constant. Now I need to simplify here, 8 with 4, I'm left with 2, and then I can rewrite as my final answer 2/5 times x to the power of 5 plus 2 times x to the power of 4 minus 5 over 3 x to the power of 3 plus 7 over 2 x to the power of 2 plus 2x plus the constant c, where c belongs to the real numbers.